Hi, everybody. It's Miss Rose. It is week 29, the week before Thanksgiving. So let's try our hardest to stay motivated for a few more days and we'll be rewarded with a nice break. So this week's theme is going to be finding the areas of trapezoids and regular hexagons. So I'm going to talk to you about trapezoids. So let's look at a couple that are on a grid, and hopefully you can see right away that you kind of already know how to find the area of a trapezoid. The first one, maybe you noticed that you could just drop this altitude right here and split the trapezoid up into a rectangle and a right triangle because you're already experts at finding areas of rectangles and areas of right triangles. The one thing you have to be careful of is make sure to split this 7 up into the 4 for the rectangle and the 3 for the right triangle. And then I can steal this 3 and bring it over here. So we have the rectangle part is base times height, 4 times 3, which is 12. And then the triangle part is base times height divided by 2. 3 times 3 divided by 2, 4.5. Yes, a decimal is fine. So the area of the trapezoid is just the total of the rectangle area and the triangle area put together. So that's one way to find the area of a trapezoid, is just to split it up into pieces. It's not wanting to write that down for some reason. All right, the area of the trapezoid is 12 plus 4.5, so 16.5 square units. 16.5 squares fill up that trapezoid. What about the second one? It's not quite as easy to just see what to split it up into. So what I would do for this one is I would drop both altitudes. Always try to get a rectangle in there. The altitude that I just drew, I counted the boxes and it's 10 boxes. And then the base, this splits up into 2 boxes, 8 boxes, and 6 boxes. So just like we did in the last problem, we can find the area. This time it's 1 rectangle and 2 triangles. So the first triangle is 2 times 10 divided by 2. So that's just 10. The rectangle is 8 times 10, base times height. So that's 80. And then the second triangle is 6 times 10 divided by 2. That's 30. So the area of this trapezoid is what you get when you combine the 2 triangles and the rectangle. So let's see, 10 plus 30 is 40. 40 plus 80 is 120. So if we counted up all those squares and put together pieces when we had partial squares, we would get 120 full squares in there. So how do you split stuff up when it's not on a grid, when you don't have the luxury of just being able to count the boxes? Well, then usually Pythagorean theorem or some harder algebra comes into play. So if I wanted to split up the base for this one, I would have to take this triangle and do Pythagorean theorem to figure out what this piece of the base is. I'd have to drop another height and subtract from 17 to see what's left over. And there would end up being a lot of steps. So wouldn't it be nice if there was an easier way, like if there was a formula for the area of a trapezoid? So let's find out how to do that. And it's going to save us a lot of work for this one. We're not going to have to split up that 17 into different parts and stuff. So here's the deal. A lot of the shapes that we've learned so far are base times height. Here's the problem with a trapezoid. You have this base, which is small, and you have this base, which is big. So which base do you use? Well, if you use the big base times the height, you'll get the area of a rectangle that's too big. And if you use the small base times the height, you'll get a rectangle that's too small. So this should kind of remind you of like the Goldilocks and the 3 bears story. So how do you find a base that's just right? If the 17 is too big and the 6 is too small, what's the just right base to use? Well, it's called the mid segment. And you can find it by taking the average of the 2 bases. So M is going to stand for mid segment. If you use the mid segment as your base, then the area of a trapezoid is just, instead of base times height, it's going to be mid segment times height. So it still falls in line with our base times height formula. It's just one base of a trapezoid is too small, one base is too big, and we want the base That's just right. So here's how you find a mid-segment. It's really quick. We just take our two bases, 6 and 17, and we average them. So how do you find an average? You add them up and divide by 2. The one thing you have to be careful of in the calculator is you have to do this in 2 steps. It's not like when we did base times height divided by 2 and multiplication and division are just inverse operations and can be done in any order. Here it's you have to add first. 6 plus 17 equals 23. Then divide by 2 and you get 11.5 for your mid-segment. The 6 is the height of the trapezoid, so we don't have to find the height. So we are already ready to find the area. We are just going to go mid-segment, which is 11.5, times the height, which is 6. All right, let's type that into the calculator and see what we get. 11.5 times 6 is 69 square units. That is so much quicker than what we would have had to do by doing Pythagorean theorem and splitting up the 17 into multiple parts. So there are times that I split up shapes, and there are times when the formula is so much quicker and easier. So let's do one more. What if we have an isosceles trapezoid? It says the sides are 34, 12, 34, and 44. So you might be wondering, how do you know which sides to label where? Well, if it's isosceles, the two legs are equal, so that has to be the 34 and the 34. So then I just see what's left over and I say, well, 12 has to be the smaller base and 44 has to be the bigger base. So I can tell right away, I can find the mid-segment. Here is the problem though, is I don't know the height. Height, we're always talking about the straight up and down height, not the slant height. So my advice, drop 2 heights, just like in one of the first problems that we did with the grid. And then if it's isosceles, the base breaks up evenly. So I'm going to drop the 12 down. And then I need to see what's left over from the 44. I like to cross it off so I don't trick myself and think that 44 is just one of the pieces. So let's go 44 minus 12. That's 32. And then there's 2 pieces left over. So I can just divide my 32 into 2 equal pieces and I'll get 16. And 16 is what's left over. And then this one does still involve algebra. I'm going to probably still use my formula with the mid-segment, but the difference this time is I don't know the height, so I still do have to do Pythagorean theorem in order to find the height. So x and 16 are my legs. 34 is my hypotenuse. So x squared plus 16 squared is 256. 34 squared is 1156. Oh, I can tell that this one's going to work out nicely because I happen to know that 1156 minus 256 is 900, and 900 is a perfect square, like how 9 is a perfect square. So square root of 9 is 3, square root of 900 is 30. So we have a height of 30. All right, on a problem like this, you have 2 choices. If you love the split the shape up into 2 triangles and a rectangle and find the area of each method, then go for it and do that. If you like the mid-segment method, go for it and do that. I'm going to show you the mid-segment method just because it's new. So I like to write out the formula, mid-segment times height. The mid-segment is the average of the 2 bases, so 12 and 44. Add them up. Divide by 2. Don't forget to add the top and hit equals before you divide by 2. So 12 plus 44 is 56. 56 divided by 2 is 28. All right, once you have that, we can just go mid-segment times height. What's the height? It's the 30 that we found. Quick calculation, and we have our area. 28 times 30 is 840. 840 square units. So this time we couldn't avoid Pythagorean theorem because we needed to know the height. If you prefer it, I'll show you the other way real quick. You could go base times height divided by 2 for the 2 triangles. 16 times 30 is 480. Divided by 2 is 240. Sometimes people don't even divide by 2 because there's 2 of them. So they just know, all right, that's 480 total. And then 30 times 12 is 360. If you add up 240, 240, and 360, you get the same 840 that I just got. So the choice is yours. If you like to split it up into shapes you know, go for it. If you prefer this new mid-segment formula, then go with that. I have one more problem for you. I think we will want to use the mid-segment for it. It's a working backwards problem. What do you do if you know the area and you're trying to find the height? So first thing I do is write down the formula. And then I say to myself, what do I know? I know that the area is 50, so let me plug that in. Do I know the mid-segment? No, but I can find it really quickly because I know the two bases. So let me add them up. Divide by 2. 25 divided by 2 is 12.5. Will you sometimes get a decimal? Yes. If one of them's even and one of them's odd, you're going to get a decimal. So all I'm going to do is plug that in for the mid-segment and then solve for h. And I have a really quick equation to solve. I can just divide both sides by 12.5. And I get my height. 50 divided by 12.5 is 4. For what? If I look at the units in the problem, I see it's 4 centimeters is the height of the trapezoid. So let's try some practice problems on the homework assignment and let me know what questions you have. Bye.